I'm John Strum, and this is RealTalk MS. It's May 4th, and we have a lot to talk about. We have a very special episode of the podcast to get into today. But before we do, I want to first say thank you to everyone who participated in the RealTalk MS listener survey. As I go through all of your responses, I'm learning a lot about who you are and the things you like most about the podcast, as well as the things that you like less. And all of that will help me stay on track, producing the kind of multiple sclerosis podcast that you really want to listen to. And now that the listener survey has officially closed, I went ahead and blindly drew a name from among all of your survey submissions. And the winner of the $100 Amazon gift card is Amy Nims. Congratulations, Amy. Thanks for listening. Thanks for participating in our listener survey. And thank you to everyone who participated. As I mentioned at the top of the podcast, this is a special episode of RealTalk MS because we're going to take a close look into the future of MS treatments. Not the faraway, distant future, but the almost ready for prime time, right around the corner future. I'm devoting today's entire episode to a conversation with Dr. Michael Kornberg. Dr. Kornberg is an Assistant Professor of Neurology at the Johns Hopkins University School of Medicine, and in addition to his clinical work, Dr. Kornberg's lab is focused on identifying novel therapeutic strategies to prevent neurodegeneration and promote remyelination in MS. Today, Dr. Kornberg is going to give us a preview of MS treatments and therapies that are on the horizon. Therapies that will likely receive FDA approval over the next few years. So if you'd like to peer into the not-too-distant future for a preview of the new therapies that will be available to you, I think this is a conversation you're looking for. In a moment, we'll meet my guest, Dr. Michael Kornberg. Innovations in technology have accelerated the pace of scientific research and discovery like never before in human history, and that includes accelerating MS research. Today, we're taking a peek just over the horizon at innovative research and emerging MS treatments with my guest, Dr. Michael Kornberg. Dr. Kornberg is an Assistant Professor of Neurology and an Associate Director of the Neurology Residency Program at the Johns Hopkins University School of Medicine. He's a member of the Johns Hopkins Immunology and Cellular and Molecular Medicine graduate programs, and Dr. Kornberg specializes in the care of individuals with MS and other autoimmune diseases of the nervous system. In addition to his clinical work, Dr. Kornberg's lab is focused on better understanding the pathogenesis of MS and identifying novel therapeutic strategies to prevent neurodegeneration and promote remyelination in MS. Welcome to the podcast, Dr. Kornberg.
Thank you very much for having me.
You know, when it comes to innovation and progress in MS treatments, there's really a lot for us to talk about. I thought we could start with some of the new attempts to target MS progression by focusing on B cells and innate immune cells called myeloid cells. First, can you explain the role of these cells in MS progression?
Absolutely. So the shortest answer is that we are still learning exactly what the role of these cells is in MS progression. So B cells are another type of cell called a lymphocyte. The other type of lymphocyte is called a T cell, which the lay public has gotten familiar with over the course of the last year because of the COVID pandemic. But B cells generally produce antibodies, and they certainly play a role in relapsing remitting MS, and they're the target of medications like ocrelizumab, ofatumumab, and so they clearly play a role in relapsing MS. There's a thought that they might also have a role in progression in somewhat different ways. So in people with progressive disease, we find inflammation in the covering around the brain, something called the meninges, and there are collections of these B cells that form there and seem to be associated with injury to myelin, kind of in the outer part of the brain, the cortex, which is really important for many different functions. And we think that might play a role in progression. And innate immune cells are cells that outside the brain are kind of our first line of defense against infections. But inside the brain, there are innate immune cells called microglia that we think play a particular role in progressive disease. So in relapsing MS, the inflammation really starts outside the brain, in the blood and lymph nodes, and the immune cells get revved up and they cross into the brain and cause trouble. In progressive disease, we no longer see that inflammation that's happening outside the brain. It seems to be trapped within the brain. And a big part of that is cells called microglia that seem to either kind of worsen the injury or promote repair. And so we're trying to find ways to alter the behavior of these cells in a way that is beneficial for people with progressive disease.
There's a new class of drugs being tested to treat MS. They're called BTK inhibitors. These drugs inhibit a specific enzyme which reduces B cell and myeloid cell activation. Can you explain a little bit about how these drugs work?
Yep. So these drugs, they basically turn off a protein that is called Bruton's tyrosine kinase. And this is a protein that is more or less exclusively found on B cells and cells of the innate immune system, innate immune cells. And kind of just like we talked about B cells playing a role in relapsing remitting MS, certainly these BTK inhibitors will play a role in relapsing MS as well. And one of these drugs, evobrutinib, has already been shown to be beneficial in relapsing MS and is moving on to larger studies. The possibility when it comes to progressive MS is that we think B cells and innate immune cells, something called myeloid cells, play a role in progression, just like we discussed. And so, there's a hope that these medications will play a role in progressive disease and slow some of those processes that we think are contributing to progressive disease. And along those lines, some of these BTK inhibitors actually get into the brain. They're what we call blood-brain barrier penetrant, which is a really big issue for treatments for progressive disease because we think the inflammation is trapped in the brain. And so we need medications that get there. And several of these drugs seem to do that. And so they are actively being studied in people with progressive disease with the hope that they will target the specific processes that play a role in that phase.
Well, being able to accurately predict MS progression and an individual's disease course requires developing reliable biomarkers. Can you tell us what a biomarker is and what its role is in diagnosing, predicting, and managing MS?
A biomarker is something that we can measure either in the blood or through imaging in kind of an easy way that tells us something either about the diagnosis or the state of someone's disease. And in MS, we still don't have a good single biomarker for diagnosis, but now we are developing biomarkers to help tell us about the state of someone's disease. And the reason that that's important is because it's really for several reasons. When people have MS these days, aside from the symptoms that they describe, the way we keep track of their disease is through things like MRI, which is very expensive. It's difficult to do that, more than twice a year, at most. And so what we are looking for are simpler tests that we can do more frequently and for less money that tell us how active someone's disease is in order to guide treatment. Biomarkers are also important in the context of studying new therapies in clinical trials because, again, with particularly progressive MS, if you are just following someone's disability the way we know how to measure that can take years to see differences. And so we're looking for biomarkers, things that we can easily test for in the blood or otherwise that can tell us how the brain is responding to a treatment in a much shorter period of time so that we can easily pick out which treatments are the most promising and take those on into the larger, more difficult studies.
I think recently the International Progressive MS Alliance has published a paper calling for some real focus on looking at a particular predictive biomarker called neurofilament light chain. as something that could be useful not only in the clinic, or as you just said, shortening the time required for clinical trial research. Can you tell us a little bit about what neurofilament light chain is and how it might be used?
Absolutely. So neurofilament light is a protein that is found exclusively in nerve cells, and not just nerve cells, but these long processes from nerve cells called axons, which is how nerve cells transmit their signals through the body. And when there is injury to those nerve cells, this protein is released and you can measure it. And so it is essentially a biomarker, a marker of injury to nerve cells, which, as you can imagine, is very useful in a number of different ways. So for quite a long time, neurofilament light could only be measured in spinal fluid. But more recently, we've developed high sensitivity tests that allow us to measure it in blood. And so we're able to tell kind of how active the injury is to the brain at any given time. And there's a lot of excitement about that in multiple sclerosis and other diseases of the brain. And how we envision using it in MS is exactly as you said. There's certain ways that we'll be able to use it right away clinically, and there's certain ways in which it will hopefully be very useful in terms of clinical studies. So the way it could be useful immediately is that when someone when someone with relapsing remitting MS has a relapse, or they have a new lesion form on their MRI, that is associated with injury happening to the brain. And so you see this spike in levels of neurofilament light. It's much easier to do a blood test to measure neurofilament light than it is to send someone to an MRI machine. And so it will be something that we could measure more frequently that tells us whether someone is being adequately treated for their multiple sclerosis. And so that's one way in which it could be immediately useful. It's also been shown to have predictive value in terms of determining someone's risk of disability in the ensuing years. So when someone is initially diagnosed with MS, if their neurofilament light levels are high, we know that that's someone who's at higher risk of having disability later on, which makes sense because it means it's someone who has active brain injury. In terms of clinical studies, the way that we hope that might be useful is, again, it tells us how much injury is happening to the brain over time. And so in progressive MS, you kind of see this slow burn in terms of the brain kind of gets smaller over time, it atrophies, and you get this kind of slowly progressive injury to nerve cells in the brain and the spinal cord. And it's very hard to measure that if you're looking at disability or if you have to measure atrophy on MRI. This is really complicated, very expensive, very time consuming. And so the hope is that neurofilament light could be essentially a proxy measure, an alternative for looking at how any treatment is impacting that injury to the brain in progressive MS. And so the hope is that if you're treating large groups of people, you might be able to see differences between them at let's say 6 months rather than having to wait 2 years, which is what's required for a lot of our traditional measures. And so there's a lot of excitement about how it could be useful in many different ways.
Some novel approaches in MS research are based on targeting viruses that might be linked to MS. For instance, previous infection with the Epstein-Barr virus has been linked to the risk of developing MS. What are we learning from recent studies that are focused on the Epstein-Barr virus and MS, or for that matter, some of the past studies that have also provided quite a bit of information?
Yes. So the association between Epstein-Barr virus and MS is, I think, one of the more fascinating aspects of epidemiology, when it comes to MS, and it's an association we've known about for a while. And so the bottom line is that almost everyone who develops MS has evidence that they've been exposed to the Epstein-Barr virus in the past, meaning that if you check their blood for antibodies against the virus, you see that at some point they were exposed. And there have been very good studies in the past showing how tight that correlation is. So there have been studies in kids and in the military that have been very convincing. So in kids, there have been studies in which children who develop MS, because some children can develop MS, when they go back and they look at blood that was taken from them before they were diagnosed and after they were diagnosed, they see that before they were diagnosed, they did not have these antibodies against Epstein-Barr virus. And their conversion to showing that they had been at some point infected always happens before their MS diagnosis. And there have been similar studies in military recruits who've developed MS, and they can go back to blood samples, beforehand and see whether they've been exposed. More recently, there have been some questions about particularly kids, where the conventional wisdom was about 15% of kids who develop MS had not been exposed to Epstein-Barr virus. But it turns out now that if you kind of go back and look at those cases very carefully, almost all of those kids actually did not have MS. They had other related inflammatory conditions. And so, essentially everyone who develops MS has been exposed to the Epstein-Barr virus. The tricky part, and I think this is really important for people with MS to understand, is that by adulthood, about 90% of everyone in the world has been exposed to the Epstein-Barr virus. So you have kind of 90% of everyone, but 100% of people with MS. And so it seems like Epstein-Barr virus exposure is necessary, but not sufficient to give you MS. There's something else going on. And we don't really know what it is about Epstein-Barr virus exposure that's so important. There are some people who think that that MS might relate to Epstein-Barr virus infection that's poorly controlled. And so there are studies going on right now for therapies that are aimed at kind of eliminating it from your body. But it could just be that there's something about the virus that looks like that myelin coating that we have around our nerve cells, and just initiates that initial response that triggers MS.
So I guess my question probably relates to the current study you just mentioned. What effect do you imagine would an Epstein-Barr vaccine have on the incidence of MS?
So that is a great question. My honest answer is I don't know. And the reason for that is because, and this is my view, there are obviously, very intelligent people who can look at the state of the evidence and come to kind of different conclusions. But my view is that we don't know right now what the root causes of that association. And there can be multiple possibilities, but I'll describe two, and which are relevant to what role an Epstein-Barr virus vaccine would have. So one is what we call this molecular mimicry. So one of the ideas in terms of why people get MS is that at some point you're exposed to something, a virus, something else. Then there's part of that virus that just looks to your immune system like the proteins that make up the myelin in the brain. And so, when your immune system develops a response against the virus, kind of a collateral damage, ends up being myelin, and you're kind of training the immune system that myelin is a foreign invader that needs to be attacked. If that is true, then an Epstein-Barr virus vaccine, that you get early in life, could prevent MS, but it also could actually trigger MS in some people, right? Because if it's the response to the virus that's the trigger to MS, then it could either make no difference, or it could actually cause MS in some people. On the other hand, there is this idea, that in people who develop MS, their immune system is not able to control that viral infection. And it's that persistent viral infection that kind of continues to drive their disease. If that's correct, then a vaccine could have a big effect in preventing MS kind of in large populations. And along those same lines, the treatments that are being developed now, because we don't really have Epstein-Barr virus vaccines on the horizon, but the treatments that are being developed are really aimed at finding cells that are chronically infected with this virus and getting rid of them to kind of get it out of your body. And those are in early stages, but those studies will actually be happening over the next 5+ years. And so I think we'll have somewhat of an answer there. But that's a long-winded way of saying that I don't think we know enough yet to know what role vaccines or any treatments against Epstein-Barr virus will play.
I appreciate the answer. I'm circling a date in my calendar now. 5 years from now, you and I can circle back and see where that research has led us. Studies have also shown that early and ongoing treatment with a disease-modifying therapy has long-term benefits for controlling disease activity, delaying progression, and really improving quality of life for people living with MS. Recent clinical trials are evaluating if early and aggressive treatment of MS with DMTs may be more effective in the long term than gradually escalating to stronger treatments over time. What can you tell us about these two different approaches to prescribing disease-modifying therapies?
Yeah, so this is, I think, a really important question, among people who take care of MS right now, and obviously an important question for people living with MS. So there are certain things that I think as MS neurologists we all agree on. The data is very convincing now that it is very important to start treatment early. That delays in treatment of even a couple years have an impact on long-term disability. And so we all agree on the benefits of starting someone on a disease-modifying therapy early on. Right now, in the MS world, we have the luxury and the challenge of having a huge armamentarium of options, and I kind of put them into different tiers of how effective they are, but also kind of their safety as well. And so, on the one hand, we have medications that are the gentlest. They're the least effective overall at stopping new attacks, new relapses, but they also tend to be the safest in terms of long-term side effects and things like that. And then we have on the other end of the spectrum, the medicines that are highly effective at stopping new relapses, new lesions from forming on MRI, but they typically come with some other safety concerns that at least we need to think about. And so the traditional approaches to treating people with MS are these escalation or early high efficacy approaches. And the escalation approach is where you start with the safest, gentlest medications, and you say, we're only going to kind of escalate you to something stronger if you show that you need it, meaning you have a relapse or new lesions forming on your MRI. The other approach is, let's start with stronger medications up front so that we know we're getting as good a control over your disease as we can. And those have kind of been the two conventional approaches. And I would say, on the whole, the field has moved more towards being kind of early aggressive, based on some large registry data that people who start on higher efficacy drugs early on tend to have a lower risk of conversion to progressive disease or less disability later on. But we don't have at this point any studies that randomize people, meaning they take two populations of people that are the same and they compare the two approaches. And the reason that I think that's so important is because MS is a very, very disease, as I think a lot of your listeners, know. There are people who have who are going to go, decades without any significant disability, and there's going to be people who have very aggressive disease and very quick disability. And so, the question is there really, a one size fits all approach for everyone? And what about the safety issues? If the really strong medications were just as safe as the gentle ones, we would start everyone on the strong medications, up front. But, what are the safety implications of starting someone on that highly effective therapy? And so there are clinical studies being done right now that compare those two approaches. So that we know kind of with a stronger degree of evidence, what the best approach is for which patients.
So is this something that a patient may want to have a conversation about with their neurologist or MS specialist so that the decision on risk tolerance and where to begin treatment with the disease-modifying therapy really becomes a shared decision?
Absolutely. That is hugely important. So I view that as a major component of choosing a disease-modifying drug with every person with MS that I see. People are very different. Some people are terrified of their disease and willing to accept high risk from a medication, and some people are exactly the opposite. The thing that they're the most afraid of is side effects from medications. And, there's no, one right answer. I mean, obviously, the way that particular, person, that patient feels is what's most important. And so this should always be a discussion, with your neurologist. And, I certainly always take that into account when we're kind of, having a dialogue about, what medication is right for which person.
It's hard to have a conversation about emerging therapies without talking about stem cell therapy to treat MS. There's been some encouraging news about autologous hematopoietic stem cell transplantation, or AHSCT, and there's also been encouraging news about mesenchymal stem cell therapy. Can you give us a brief update on these still experimental treatments?
Absolutely. So I get asked about stem cells by my patients quite often. And I think, one point that I think is really important to make is that these types of stem cells are actually quite different, and they serve different roles. And so, when people in general think about stem cells, they're often thinking about cells that can kind of form new nerve cells or new myelin and kind of repair the damage that's been done. But a stem cell is just a cell that can self-renew and has the ability to form different types of cells. And so hematopoietic stem cells are kind of a different beast altogether. And so the idea there is that we know that MS is an autoimmune disease where someone's immune system is overactive. It's targeting, myelin, as a foreign invader. And those autoreactive cells are kind of floating around in our blood. So the idea behind hematopoietic stem cell transplant is that people are treated with high doses of kind of chemotherapy type medications that basically just get rid of their immune system. It just ablates their immune system. And as you can imagine, that's not a safe, long-term plan. And so once that's done, the immune system is replenished with bone marrow stem cells that are taken from that same person. And so the idea there is to kind of reboot the immune system, kind of like restarting a computer. You're getting rid of, all of those cells that are causing problems, and you're starting the process fresh. And so because of that, it has the potential to actually solve the underlying problem. It won't repair damage that's been done before, but prevent the capacity to have additional relapses or attacks in the future. But there's also going to be some, potential dangers, at least in the short term, of that approach. Mesenchymal stem cells are a bit different. They are not intended to reform your immune system. The hope there is that these cells are either secreting things that kind of help calm down the immune system, or more importantly, are promoting actual repair within the brain. Repair of myelin, recovery of nerve cells, or in some cases, there's a hope that they might actually even get into the brain and form, new myelin forming cells. The caveat that I have to give is that we still have a lot to learn about mesenchymal stem cells. So even that term is very foggy, because they can come from many different places. Depending how they're treated outside the body, they can have many different roles. And so we're still a long way from knowing what role that they'll play. And even if they'll play a role, exactly where we need to get them from, how we need to treat them. But there's a hope that they might play a role in recovery, not just preventing future attacks.
And while we're in the process of giving out caveats, I think another caveat worth mentioning to our listeners is that when I introduced this particular topic, I went out of my way to say still experimental. And right now, I know an awful lot of people who are anxiously looking for relief from MS can easily be attracted to some of the online offers from what I call so-called stem cell clinics. And those can really lead down a dangerous and sometimes extremely unfortunate path. I'm wondering if you'd like to make a comment about stem cell treatment, where it is today.
I would, and I appreciate you bringing this up, because as you said, people with MS are very understandably looking for answers and things that are going to improve their current symptoms. If you're living with MS, if you have a loved one with MS, it's heartbreaking, and I completely understand this desire to be proactive. But when it comes to stem cell therapies, the potential risks of pursuing these kind of outside of either, a well-designed clinical study or, with experienced providers is quite significant. And so that relates to both hematopoietic stem cell as well as other things like mesenchymal stem cells. So there are a number of clinics, that will offer to harvest, a person's own mesenchymal stem cells and either infuse them, into their blood or even into their spinal fluid. And because at this point there's no FDA-approved treatment, many of these clinics, you don't know what they're actually taking from you and what they're putting in. Besides the cost of it, the potential dangers are real, and we've all seen people who have had bad outcomes. And beyond that, I think it's most important to say that we really are quite far away from knowing exactly whether any mesenchymal stem cells will help, and if any will help, exactly where we need to get them from and how we need to treat them before we put them in your body. And so we just are not there yet. And so I offer a lot of caution there. And similarly with hematopoietic stem cells, remember that the first part of that treatment is being treated with essentially chemotherapy drugs. And there are significant dangers associated with that. And in clinical studies in centers that have a lot of experience in doing stem cell transplants, particularly in people with MS, that safety has improved significantly over the past 10 plus years. But there are risks, including mortality from that sort of treatment. And so at this point, we urge people, if they're interested in these studies, ideally you do it only in the context of a well-controlled clinical study at a reputable institution. If you are pursuing something outside of that, at the very least, it has to be a center that has experience. And I would refer you to the National MS Society website, which very nicely puts together kind of access to links for governing bodies that report, particularly for stem cell transplant, centers that kind of adhere to these guidelines and have that sort of reputation. But it's a very important point, John.
And we'll go ahead and add links to the MS Society's page, or actually multiple pages of information on stem cell transplant for MS. The last area of research that I'd like us to touch on is some of the work that's focusing on remyelination. I know that some of your research is focused on neurodegeneration, so I'm hoping you can help our listeners understand what neurodegeneration is and what you and your colleagues are learning.
Absolutely. So neurodegeneration just means injury to the nerve cells of the brain. We think of multiple sclerosis as a demyelinating disease because, the main target of the immune system is myelin. But particularly in later progressive stages of disease, we also see injury to the nerve cells themselves. And that seems to be actually the greatest predictor of disability is how much injury you have to nerve cells. And so, we have gotten very good, with anti-inflammatory therapies that stop future attacks of inflammation. But what we don't have right now is anything that really repairs damage that's been done. And so that's remyelination or myelin repair. And we don't have anything that in later stages of disease, like progressive disease, that slow that brain atrophy, that neurodegeneration, that we feel very confident contributes to progression. There we have, still have a lot to learn about, what is driving those processes, why myelin repair fails, why nerve cells degenerate over time, particularly later in disease. But we have a lot of good leads. And I think, scientifically, we're in a very exciting point in that respect.
That sounds incredibly encouraging. So we look forward to you and your colleagues learning more and seeing how that materializes into new treatments and the day where remyelination, in order to regain lost function, becomes something that people can be treated for.
Yes, well, I like to strike a cautiously optimistic tone because I wish I could say that there was myelin repair or neurodegeneration treatments that were, on the immediate horizon, within a few years. I don't think that's the case. I often like to say that if you just think back to what the state of MS care was even 10 years ago, over that period of time is really the explosion in disease-modifying therapies. Things have changed so much in terms of the treatment of relapsing remitting disease. I do optimistically feel like we are, on the brink of something similar when it comes to myelin repair or treatments for progressive disease. Where we have learned so much about what causes these processes over the preceding 5 to 10 years. Therapies are in development that I think are very promising, and so I do have a lot of hope for what we'll see, over the next decade. Even though I can't promise that there's going to be anything, within the next couple of years.
Well, that's incredibly exciting. Back in the late 1960s and early 70s, as large numbers of American tourists were really discovering Europe for the very first time, a lot of travel companies offered tours with titles like See 10 Countries in 5 Days. And those tours were infamous for speeding you through all the important sites at what sometimes felt like breakneck speed. I feel as though we just took the emerging MS research equivalent of seeing 10 countries in 5 days. And Dr. Kornberg, thank you for being an outstanding tour guide. Thank you for all that you do to improve the lives of people living with MS. And thanks for talking with me today.
Absolutely my pleasure, John. I very much enjoyed it.
That's going to wrap up this episode of RealTalk MS. RealTalk MS is powered by the National MS Society. And you can share this episode of the podcast by letting your friends or family members know that all they have to do is point their web browser at realtalkms.com/192. You'll find that link in today's show notes so you can easily copy and paste it right into an email or text. And now I have a favor to ask. It would mean a lot to me if you'd leave a rating and review for RealTalk MS. Just point your web browser at realtalkms.com/review, and you'll see links to the different online destinations that you can choose from to leave that rating and review. And those links are going to be different for each of you because they're based upon the software that you happen to be using to listen to podcasts, or at least the software that you have installed on your phone, tablet, or desktop computer. For instance, if you happen to be using an Android phone to listen to RealTalk MS, you won't see a link to leave a rating and review on Apple Podcasts because you can't leave a review on Apple Podcasts if you're using an Android phone. I hope that makes sense. It's just a little bit of technology that makes leaving a rating and review super easy. So I hope you'll take a moment to leave a rating and review for RealTalk MS, and you'll find a link to do that in today's show notes. I'm John Strum. Thanks for listening. Stay safe and make healthy choices.